Okay. So this topic is really short. That's all that there is, just over here. So let's just go do some examples quickly, because these problems are quite straightforward. It is the questions at revision exercise or review exercise at the end of the topic is what we are more interested in, because that's the type of question that we'll be seeing. Okay? So now just quickly, in your pairs, somebody do part A, somebody do part B, and I will show you the answer for try it 4. Use any of the formula that you have learned and use it correctly. Too simple already, right? Okay, now find the gradient of, okay, no, let's not do this. It's already given to us. Okay, let's try it 5. Try it 5, it says that there's a line joining the points Q and R, and it intersects the x-axis at the point T. Find the gradient of the line. Okay, part A. Do it by yourself. I'll do it concurrently with you. When you look at my presentation, do I just have this? No, right? Because if I just dump you a bunch of numbers, added or subtracted and divided, I don't know what it is. So you must always annotate. You must write stuff that allows the marker to know what you're doing. And in this case, since you're calculating the gradient, so write down gradient, G-R-A-D. Okay, and gradient, you are gonna be seeing many different gradients in one single question. So to make it clearer, this is what you can do. As a subscript, write down, in this case, QR. Gradient of the line QR. Okay, it's just like in A maths, we had our A naught. Remember? For our exponential, A naught, then e to the power of 3t. Then we have A equals to something like this. Then where A naught is our original mass, something like that. So this naught over here tells us information. In this case, the QR tells us that we are talking about the gradient of the line QR. Okay, now part B. Find the coordinates of T. Well, we know that the line intersects the x-axis at a point T. What does this phrase give us? This tells us that y equals to 0. The y coordinate is equal to 0. So let coordinates of T be, what should we let it be? What would you like it to be? X, 0. Now some people will put x, y. Then they realize they have two unknowns they cannot do, because they did not take away from the question that, hey, intersects the x-axis, therefore y must be 0. So since I have the coordinates of T as x and 0, I know the graph is going to be slanted, sloping down. Probably something like this. Okay? Or it could be in this case. I don't know. It's going to be slanting down, and this value will be x, 0. This is my point T. Either this case or this case, T, with x, 0. Okay? These are the two possibilities. Now, in order to find the x coordinate, I'm going to make use of a special property. That is, the points, they lie on the same line. Point Q, point R, and point T. They all lie on the same line. So what can you tell me about the gradient of a line segment joining any of these 2 points? Must be the same lah. Okay? So whether you want to choose to start off with, therefore, gradient of QT equals to -half. You can choose this, or you can choose, therefore, gradient of RT equals to -half. Either the blue or the black option will work for you. all you need to do is to just substitute in. Okay? So let us try with the first option for qt. Gradient of qt must be equals to q and t 3 minus 0 over negative 2 minus x. This will give me 3 over negative 2 minus x, which is negative half. Therefore, all the negative can cancel. 2 plus x equals to 6, x equals to 4. Okay? So based on this, can you tell me whether it's the first graph or the second graph? First, must be the first, because my x is a positive value. So this being 4. This cannot be equal to 4, because it's a negative number. Okay, so let me remove this. Now if you chose to use the blue color option, let's try and see gradient of RT. Now I'll be comparing this with this. 0 minus negative 1. X minus 6 gives me 1 over x minus 6, which is negative half. So this gives me negative 2 equals to x minus 6, x equals to 4. Same. Okay? So this is based on the property that for points on a straight line, the gradient of any 2 points, or of the line segment of any 2 points, will be a constant, because they all lie on the same line. All of them have the same slope. Any questions? Okay, what does the graph of y equals to negative 3 over 2 look like? Over here. This one. Yeah, it's a straight line. All of these are straight lines. But when you guys say straight line, in your mind you're actually thinking about horizontal line. But I don't know why the word comes out as straight line. You get what I'm trying to say? So you must make a distinction between straight line, horizontal line, diagonal line, vertical line. So for this one, it is a horizontal line. What is the gradient? How steep is it? Yeah, it is. The value of the gradient is AB equals to 0, because it is flat. What is the gradient of our classroom floor? It should be 0, like it's flat, it's horizontal, right? What is the gradient of the stairs leading from one level to another level? Will it be 0? It won't be 0. Depending on the ratio, the rise over the run, then you can tell whether it is greater than 1 or less than 1. Okay? But logically, do you think the gradient will be more or less than 1? Less or about 1, right? Because now I want you to visualize the staircase, the steps. Do you, are the individual steps, right? Do they look more like this? Or do they look like this? You get the difference? So it is like this, isn't it? So this will tell us that the rise over the run should be less than 1. The rise is less than the run. Otherwise, if you get stairs that look like this, it's very difficult to walk on. It's very difficult to climb. So the next type of line, we have this, x equals to 2. What is the gradient of this line then? Huh? Is it 0? You must always remember, gradient refers to the slope. You always remember, is it difficult to climb or not? So for the horizontal one, it is super easy, it is 0, it's flat. For this one, can you try climbing it? You cannot. So here we have undefined gradient. Gradient equals to undefined. What does this word undefined mean? Or infinity? Why infinity? You know why infinity? No, this horizontal line also goes on forever. So what does gradient undefined or gradient infinity mean? What does infinity mean to you? I don't want to go there. What does infinity mean to you? Never ends. You mean like 0.11111, this is infinity? No, right? Okay, what does infinity mean? Very big, right? It's so big that you cannot give it a value. Because whatever value that you think in your mind, I just need to say I plus 1. Then it's bigger than your number already, am I right?
So infinity plus 1 equals infinity.
Yeah, exactly my point. So infinity is a number that we cannot even imagine. Okay, so why am I telling you all these things? Which one, now you tell me, which one is steeper? The red graph or the blue graph? Blue is steeper, right? Which one has a larger value of the gradient? Blue. Okay, it's larger. What about the green line now? Which one has a larger value?
Blue.
Green or blue?
Blue.
Green, it is steeper, isn't it? Now, if I give you a graph that is perpendicular to the y-axis, parallel to y-axis or perpendicular to the x-axis. So, meaning this vertical line, what is its gradient now? Is it going to be bigger or smaller? It's going to be bigger, right? It's the biggest ever already. And that is infinity. Another way to look at it, we have our formula. Okay, let's say this one over here, let's call this 10. So 1, 10 and 1, 2, for example, y and x. I want you to use the formula rise over run, or your y2 minus y1 over x2 minus x1. What do you get? Yeah, you get 10 minus 2 over 1 minus 1, which is 8 over 0, which is undefined. We are precisely dividing by 0. That's why it goes undefined. But why is it that when we divide by 0, we get an infinity? No. Why is it that when you divide by 0, you get a big number? Why must that be so? Let's assume you have one pizza. Okay, you divide it by 2. What do you have left? Half. 1 divided by 1. What do you get? 1 divided by half. 1 divided by 1 over 100. So you see, I'm dividing by numbers that are getting smaller and smaller, right? I'm dividing by numbers that are getting smaller and smaller, and my result will be numbers that are getting bigger and bigger. So the moment I try to 1 divided by 1 over 1 million, then I'll get 1 million. So what is the smallest number that we can divide by? I mean, if we continue this trend down, it will be 1 divided by, why did I write this? This will be 1 divided by 1. Oh yeah, 1 over 1, 2, 3. So when I divide by 0 over here, because it gets smaller and smaller, I will start to get a huge number. So big that we call it infinity. Okay? What about negative number? Then the sign will just change lah. So let's say you 1 divided by negative 1 over 10. Then you get negative 10. Yeah, this is small. This is a small number. Isn't a negative number smaller than 0? Yes, it is. But it means something else to divide by a negative number. Okay, I need to move on already. This one, no need calculation. Tell me what's the gradient. Okay, this one? Undefined. Okay, that's all for gradient of a straight line. Yeah. Do you want homework for this? Don't want? Too simple, right?
Wait, Mr. Wong, if you give us homework for these 3 questions, disappear, right? Then today.
No, don't know what you're talking about. Anyway, let's move on. Equation of a straight line. Have you learned this also? Yes, you have. Y equals to mx plus c. What does m stand for? Gradient. What does c refer to? Y-intercept. Okay. Now, if I tell you that gradient is positive, what does it imply? It slopes upwards. Gradient negative, it slopes downwards. If I tell you that okay, gradient equals to 0, then it means horizontal. Gradient is undefined, vertical. These are the only 4 possibilities for a straight line, isn't it? You either slope up, slope down, horizontal, or vertical. No other possibilities. What does a graph look like when I tell you that gradient is positive and C is positive? What does this graph look like? It slopes upwards, and where does it cut the y-axis? So it must look like this, right? No other options. Gradient is negative, C is positive. What does this look like?
Opposite, mirror image.
Y-intercept above the x-axis, okay, then sloping down, like this. No other option. Okay, gradient, positive, C is negative. Okay, what does this look like?
Below the x-axis.
Like this? Okay, and we have just a few more cases, yeah? Gradient, negative, C, negative. What does this look like? Like this. Okay? So based on this, we can also tell where the graph will cut the x-axis based on our sketch. Then of course, we've got the case of C being 0. So gradient, positive, C equals to 0. At the origin. Then gradient, negative, C equals to 0. Then it must look like this. Okay? Simple? Okay, let's start with example. No, I don't want to do example. Try it. Let's try it 7a. Find the equation of a line with a gradient for 2/5 and passing through the origin. Before we try this ourselves, I've got a question I need to think about. How much information do you require before you can draw a line?
2 points.
Basically, it's the same type of question as how much information do I need to give you before you can come out with a unique triangle? The part about congruency lah, right? So, cause triangle there are 6 parts, right? 1 angle, 2 angle, 3 angle, 1 side, 2 sides, 3 sides, right? I don't require 6 items in order to draw a unique triangle. All I require will be 3, either 3 sides or 2 side, 1 included angle, or
3 angle.
2 angle, 1 side, or right angle, triangle, hypotenuse, and a side. Those were our congruency tests, right? Okay, so now in a similar fashion, right, how much items do you need before you can draw a unique straight line?
2 points.
Okay, 2 points, so the 2 coordinates. If I give you these 2 points, you have no choice, right? The line must look like this. Okay, what else? Then that means when I give you, let's say 1, 0 and 2, -1, you must be able to tell me the equation of a straight line already. This is sufficient. How do you do that? I get to that in a while. Besides having 2 points, what other ways are there to get a unique straight line? Gradient and y-intercept. Must it be the y-intercept? Must it be the x or y-intercept? Must it be? What if I give you a random point? Let's say I've got a line that passes through this point 3, 8 with a gradient of 2. Are you able to draw a unique line? Is this the x-intercept? Is this the y-intercept? No, it is not. As long as I give you the coordinates of 1 point, I give you the gradient. And so I say the gradient is equal to 2. I know it's going to be sloping this way, isn't it? It's going to be sloping up. So this gradient equals to 2. Then it is sufficient for you to draw a straight line. Also, it is sufficient for you to get the equation of a straight line. So in summary, right, as long as you are given either 2 sets of coordinates, okay, or 1 set of coordinate plus gradient. That means you can find gradient of straight line to be y equals to mx plus c. Take note that this 1 set of coordinate can be x intercept or y intercept as well. Just like your two sets of coordinates over here. Can? Okay, in order to write down y equals to mx plus c, which are the variables? Y, mx, or c? Variables. X and? Yeah, x and y are variables. So the constants will therefore be? M and c. So as long as I know the gradient and the y-intercept of a line, I can find the equation of a straight line. Okay, let's take a look at equation, option number 1. Let's say I'm given two sets of coordinates. Are you able to find the gradient?
Yes.
Yeah, you can. You can find the gradient. So m is not a problem. Once you manage to find the gradient, are you able to find the y-intercept? If it is not given. Okay, so we'll look at the example right now. Find the equation of a line that passes through this set of coordinates and this set of coordinates. See, two sets of coordinates given to you. You are expected to be able to find the equation. All we need to do is to first find the gradient. Gradient, everybody can do it. Okay, gradient equals to 3 over 4. Don't need to spend time doing that. Once we have the gradient, we substitute it into our y equals to mx plus c. Gradient is found already. So y equals to 3 over 4x plus c, where we all know that c will be our y-intercept. Make sense so far? Now that we have this, this is my new equation, but I need the value of c. Sub in which one? A or B? Any set, A or B, because both A and B lie on the line. So in this case, your textbook chose to substitute in A. I shall now choose to substitute in B, just to verify. Sub B, which is -5, -4 into equation number 1. So y, which is -4 equals to m, 3 over 4, -5 plus c. And over here I get -4 equals to -15 over 4 plus c. C equals to 15 over 4 minus 4, which is times 4 times 4, -1 over 4. Same. Can? So this is the approach to finding the equation of a straight line when you are given 2 points. Standard way, just like our simultaneous equation. Got very standard way on substitution. That's it. No need to think so much. Finding equation of straight line, given 2 points, this is the way. Find gradient, write down equation, sub coordinates, find c. Done. So you get to try it. 8. Find the equation of a line that passes through the points. Okay, let's do B. Okay, try it for yourself. Okay, try it. 8B. I will sketch the graph. R is -4 and 5. Here is 5, y and x. And S, -1, 5. So another point over here. So joining these 2 points up, I realize, it's a horizontal line, right? Therefore, y equals to 5. Gradient of RS equals to 5 minus 5, and then straight away you know it's going to be 0 already, unless the denominator is also 0. Then you have a problem because it will be the same point. So 5 minus 5 over -1 minus -4, which is 0. So I know in my mind it is a horizontal line. If I already know it's a horizontal line, then I can straight write down that y equals to 5 already. But if you choose to follow the exact same steps, we will have, let the equation be y equals to 0x plus c. Then you sub either -4, 5 into equation number 1, or sub -1, 5. Also, you will get the same answer. So we get 5 equals to 0 times -4 plus c. C equals to 5. So now you sub it back into our equation to get y equals to 0x plus 5. And since nobody writes 0x, our answer is y equals to 5. Okay? No discrepancy between what is shown in the graph and your working. I saw some of you write down the gradient as undefined. You are already confusing between 0 divided by something versus something divided by 0. There's a difference between a horizontal and a vertical line. One is flat ground, very easy to walk. The other is a vertical wall, cannot walk on it. Okay, next. Some of the terms that you need to be familiar with, gradient-intercept form. Okay, because a line can have different equations. For example, y equals to mx plus c. This is one form of the equation that you can take. It could be y minus mx equals to c. This is again another straight line, but it has a different form. Okay, so for the gradient-intercept form, it just means that I will be able to tell the gradient and the intercept, y-intercept, from the equation straight away. And it must be in the form y equals to mx plus c. So first, can we convert in our try it 9? Part A, can you convert this into y equals to mx plus c? Okay, do that now. 30 seconds, doesn't take you long. Okay, so this is our gradient-intercept form. Hence, state the gradient. What is the gradient?
2 over 3.
Gradient equals to 2 over 3. Y-intercept equals to 4 over 3. That's it. Simple. Okay, notice that I skipped past the homework also. Okay, because now we are at 5.4 already. Geometric problems involving the use of coordinates. This question, you can just read it yourself. Okay, read through the example. Okay, this one. Example 11 is a more typical type of exam and test question that you will see. Okay, so take some time to read through the question first. Gradient of AC is found, and we see that gradient of AC, okay, half. So gradient of AC is half. What do you do after that? Sub in either A coordinate or C coordinates into our y equals to half x plus c to find the value of c. Then it's done. Sub it back into our equation. So that is the approach to our finding equation of the both lines. So now we have these equations. Okay, 2 equations done already. Find the coordinates of E. Exactly what I said. Find the coordinates of E. How? Simultaneous equation. So equation 1, equation 2, substitution, you get point E, 3, 5. Okay. Let's go back to the question. Show that A, B, E, C, D, E are similar. A, B, E, C, D, E. Okay, recap. What are the tests that we can use to show that triangles are similar? SSS. So you say SSS, you're referring to the ratio of the sides. Okay, not that the sides must be exactly the same. Besides your SSS, what else can you use? Angle, side angle. Angle, side angle. Okay, SAS, the ratio of the two sides plus the included angle. And one last one. The most popular similarity test. What is it? The AAA test. 3 pairs of angles are the same. In this case, are you able to find angles? Can find angles or not? No. Cannot find angles. Then how? Should I consider my AAA? Should I? No, I shouldn't. How about our SAS? No. Then we're only left with SSS. Can find the length of this line? Yes. Compare with this one, right? Then this one and this one, this one and this one. Find the ratio of the 3 sides. All same, proven, as shown in your textbook. Now I want you to think of another method. Not by using SSS. You go by either SAS or AAA similarity test. Can it really not be done? Okay, Shihan says that vertically opposite. Yeah, I see vertically opposite angles over here. What else?
Can you use the area?
How to find areas?
No, like you draw like rectangle.
Then you start counting square.
Yes.
No. Okay, besides our vertically opposite angles, what other angles do you see? Are there any more? Alternate? Yeah, they never say it's parallel. So how can you say that?
Use a ruler check.
So I hear people say prove it. Gradient. Okay, how? Where? Which one is same gradient? BC and AB. Yeah. As long as you can prove that these two gradients are the same, you can use parallel lines. This alternate angles or this alternate angles. So actually you can also use our angles to prove it. Can? No, go and watch the video. Okay. Let us just do try 11, part A and part B. Okay, we're down to the last example already. With time to spare. When you read example 12, just read the question, no need to do. Draw the graph of V against T, describe the relationship, okay? That's not difficult. So it's drawn for us over here already. We see that it is actually a straight line. So they have a linear relationship. So that's part A. As your time increases, your volume increases. Is it volume? That's V. Yeah, volume increases. Okay, no problem. Part B, express the equation in the form V equals to mt plus C. Now this one over here, I want you to put above it your y equals to mx plus C. Y equals to mx plus C. So see the relationship. How it isn't always y and x. In this case, we have v and t. As your t increases, your v increases. So since it can be written in the form y equals to mx plus c, we are going to get a straight line as shown in the graph. So that is done. Find a gradient. Gradient, you can find it easily. Then the intercept is exactly 10. Once you have the graph, you are expected to read the y-intercept of your graph. Don't go and bother calculating. Find the time when the water is 38 cubic centimeters, so just read off your graph. Now part D, interpret the meanings of M and C in the relationship. Let me write down the value of M first. So M is 8, C is 10. M equals to 8, C equals to 10. Okay, this is what I'm interested in for this question. Part D. Interpret the meanings of M and C. Okay, let's start. What do you think C refers to? You better not tell me the V-intercept, because that's not telling me anything. C equals to 10. In this context, because now there is a story, it's not just pure numbers, there is a story behind it. What does the 10 refer to? Volume is 10. That's not enough. Volume of 10. So what else can you tell me about C being a value of 10? Okay, so keywords will be start, 10. So basically it tells us that when time equals to 0, that is at the start, the volume is 10. Okay, was that given in the table of values?
Yes. Not the table of values.
Okay, so you see, in our table of values, right, they didn't give us the initial volume. They only told us the volume at time equals to 1, 2, 3, 4, 5. But when you draw a graph based on these values, you extend the graph to cut the y-axis. Extend the graph to cut the y-axis, you see that it has a y-intercept of 10. So that tells us that at the start, the body of water is 10 cubic centimeters. Then what does gradient in this case tell us? What does the 8 refer to? Rate of water, what?
Increasing.
Okay, so I teach you a phrase. And you should find this phrase familiar. Rate of change of blank with respect to blank. So gradient equals to, this will work for physics also. Because you've seen this, right? Rate of change of what usually goes into the blank? Velocity with respect to time. Okay, let's say we have this case. Velocity with respect to time. What is this definition for?
Acceleration.
Yeah, this is our acceleration. Which means that the gradient of our velocity time graph equals to acceleration. Okay? This is what it means. So if I have rate of change of distance with respect to time, what does this give me now? This is the definition for speed. Which means that the gradient of the distance time graph equals to speed. Okay? Now in this case, what do we have? In this actual example, rate of change of volume. Okay? Volume with respect to time. So the gradient tells me how fast the volume increases as time passes. Understand what I'm saying? Okay, just like our acceleration is how fast your speed changes, how fast your velocity changes as time passes. Then speed is just how your distance changes as time passes. Alright? This is particularly useful when the horizontal axis is t. But sometimes it is not t. Sometimes it can be things like money. And over here, this could be a number of tables, for example. So then you must tell me that the gradient refers to the cost per table, something like that. Understand? You cannot tell me rate of change of money lah, with respect to what change of table. Okay? So you must make sense of the question first. This is useful if the horizontal axis is time. Can? Okay. Let's go to our homework questions. Revision exercise 5. So from 5.1, 5.2, 5.3, 5.4, you're supposed to have 3 questions each, right? 3 times 4 is? Well. Okay, since I don't expect you to do 12, let us choose